The first part of this is, does fisheries eco-certification improve resource status and alleviate fishing pressure? And I want to acknowledge my co-authors and colleagues on this. Myself, Sarah Blackstock, who's in the audience here, who worked on, this is essentially her master's thesis, so that's why Sarah is in bold. And Hiro Shida, who will talk following me, and finally Marie-Joëlle Rocher from Ifremer in France, who also worked on this. So the first thing I'd say, why did we do this project? And I've been involved in eco-certification in a number of fisheries through the MSC Stewardship Council. And I always, the fisheries I worked on, I thought, well, this is working pretty well. And I just took it kind of as a matter of faith that the program was working as it was intended. But it's been controversial. There have been criticisms of eco-certification and how well it's worked. And there have been debates back and forth. And so it's become somewhat of a scientific issue. And so we thought, well, rather than just acting on our opinions, we should try to really look and see if there's a data-driven approach to really measure how well it's working. And that was really the impetus for this project. So there's certainly a scientific debate, but also it's of practical importance because as fisheries in New England decide whether there are a number of fisheries that are already certified in the Northwest Atlantic in the US and actually more in Canada, as they decide whether they should invest in certification, it would be useful for those fisheries to actually have some information about what the benefits have been and what the experience has been in other fisheries that have a history of certification. So that's the practical importance of what we were doing. And even with, I should say, even within our co-authors, there's perhaps a degree of skepticism about actually how well it's working. So we thought, well, let the data decide. So that was, so if the talk perhaps seems somewhat technical, the reason it's technical, I'll apologize in advance, is because we really wanted to do an analysis of this and not just go on what our opinions were. So a bit of background. Well, overfishing is really a worldwide burden, marine fisheries around the world. Even though we've perhaps turned the corner about overfishing for most fisheries, even though the rate of fishing has declined, there still remain many fisheries in the world that are overfished and require rebuilding. So when Worm et al. Did their paper in 2009, they calculated that, or they estimated that 63% of the fisheries that were analyzed in that paper require rebuilding. So eco-labels have emerged as a market-driven approach towards sustainability of fisheries. The principle is quite simple. That is, that if products are eco-labeled, then consumers can differentiate between products that are sustainable and ones that don't have the label, and that provides the motivation for fisheries to become more, and management systems become more sustainable. So that's the principle of it. And then carrying on from that fisheries that do become certified in that eco-label should see some benefit either in their market share or price differential that would benefit the fisheries that do seek certification. There have been a number of studies of how well it's working. Many of these have actually been done by the MSC itself or other groups, but they're really tracking the fisheries that are going through the certification process and measuring the improvements that accrue to the fisheries before and after certification. What hasn't really been done is comparisons of fisheries certified and non-fisheries, similar non-certified fisheries, to actually do a kind of controlled treatment comparison to see whether there's actually an added benefit of the certification, either in sustainability or the economic benefits. And that's really what we were trying to do. We were trying to do a controlled treatment comparison of certified and non-certified fisheries, which really hasn't been done before. And I'll explain how we did that. So there are a number of eco-labels that you might see on seafood. Here are three of them: the MSC, the Friends of the Sea, Oceanwise, and there's been other labels that have been appearing. There's a proliferation of eco-labels to the extent that perhaps it's leading a little bit perhaps to confusion among consumers about what they actually represent and what they actually mean. By far, the most common is the Marine Stewardship Council, which is an independent nonprofit headquartered in London. And as a running tally, now there are 53 species and 224 fisheries are now certified by the MSC. So it's certainly the longest running certification program, and so that it has the longest track record. So that's why we focused on the MSC label, not because we're trying to pick on it, but because it's certainly the, if you will, the gold standard of eco-labels and has the longest history. And so if there are benefits to be measured, that's the place to look. And I guess I should ask you in the audience, how many of you have actually seen this MSC label on products that you might have? Yeah, okay, yeah, so it's pretty widely distributed. And I should say that even though you can certainly see the eco-label on this fillet of fish, this is in Europe, you might not see it in the US, but one level that it operates on is on the consumer level, where you can actually go and see the label, but it also operates on the wholesale level. So supermarkets, chains like Walmart or Safeway may say that they're only going to buy certified seafood. It may not actually carry the label, but they're making the wholesale decision that we only carry MSC certified, and so it's not the consumer making the choice, it's the vendor that's making the choice. Okay, let me turn to, well, what makes a certification scheme successful? One is the improved status of the target fish stocks. So that's one of the main things, that to be sustainable, that the fish stock needs to be maintained at a sustainable level. And that's really the one that we targeted for this research, or that we focused on, because that's something that can be measured. You know, there are stock assessments that measure the status of the stock, and that's something that is measurable. Also, there's the contribution that the eco-certification is making to the ecosystem, that is in mitigating or minimizing the ecosystem effects of the fishery. And that's certainly important, but it's one that is actually very difficult to measure. Although it's one of the principles, you know, even defining what we mean by the health of the ecosystem is a little fuzzy, and it's not something you have hard numbers on. So that's one that we have not focused on. And the third thing is what's the market benefit for certified fisheries? Certification is very expensive, and you see the numbers there, and it's expensive for a reason. That's because the certification process is very rigorous. It involves fisheries experts, and so there's perhaps no alternative, no way to cut the corners to make it less expensive, but those costs are borne directly or indirectly by the fishing industry. We recognize that there are other criteria which to, you know, other important ways that certification schemes can have benefits that we are not looking at, and here I was going to look at the economic benefits. Okay, so the objective of the study is to evaluate the conservation benefits of MSC certification on a global scale, and we test the null hypothesis of no difference in stock status trends between certified and non-certified fisheries. So we want to compare certified fisheries with non-certified fisheries that are as alike as possible as the certified ones, but they don't have the eco-certification. So that's our objective, and I'll start with a few little background definitions. So there are two metrics related to stock status that we looked at. One is the spawning stock biomass. That's a measure of the abundance of the stock over time. And the second one is the fishing mortality rate, which is a measure of the fishing pressure on the stock. So that's a rate per year. And these are standardized relative to reference levels. So the plot on the right is indicating this is for blue marlin. It's not one of the species in our study, but it's a nice phase diagram. The bottom is the spawning stock biomass. Here, yep, and it's relative to its MSY level. So 1 means it's at its MSY level. On the y-axis, fishing mortality rate relative to its MSY level. So for spawning stock biomass, you want to be above the reference level. That's why this is green. And for fishing mortality rate, you want to be below the reference level. So this quadrant is really where the fishery should be. The red area is where the fishery doesn't want to be, and the yellow areas are intermediate or transitionary. The points there are, that's the trajectory of the blue marlin stock over time, starting from a condition here where it was lightly exploited. The fishing mortality increased, the stock went down, and it was overfished for a while, and now the fishing mortality has come down to below its reference level, and the stock biomass has increased. So that's kind of a good trajectory for blue marlin. So what we want to do is look at these trajectories in spawning stock biomass and in fishing mortality for certified, and then also for non-certified stocks, and to compare their trends over time and see if we can detect a difference. So we're looking at trends in stock status, and we're using this treatment control design. So the species included here are listed here. There are 6 species, or taxa, and you can see them. Alaska pollock, herring, plaice, the hake, saithe, and rock lobster. So we basically have 3 kind of whitefish. We have a herring, a forage fish, and we have 1 crustacean. And for most of them, we're looking at the same species. But you notice for hake, we have 2 species. They're in the same genus. And for rock lobster, there are 2 species they're in the same family of rock lobster. So we're trying to make them as similar as possible among species. So these are really taxonomic comparisons, and I'll refer to them as taxa. So you might wonder, well, if there are 53 species that are certified, why are we only looking at 6? And that would be a good question. And the answer is that many fisheries have only been certified recently. So there's no real history of performance. If it's only been certified in the last few years, we don't really know how it's performed. And also, we had to ensure that we had a good control stock. For each certified one, we had to ensure that we had actually a good control. And not all the certified ones have good controls, so we couldn't include them. So we have this set of 6 taxa that represent fish stocks from different parts of the world that we're focusing on. So the overview of the study is, first, we used this method called propensity scores to ensure that the control treatment comparisons we made were appropriate, that we want to exclude control stocks that were different for some reason that would make them not to be inappropriate controls. And we use this method of propensity scores, which is widely used, especially, I guess it's used in econometrics. So it's an accepted method of finding good matches. We normalize the data because fish stocks are different sizes and they have different rates of exploitation. We standardize them to their reference levels. We perform the analyses at the level of the taxonomic group or species by fitting linear models to estimate the trends in spawning stock biomass and fishing mortality. And I'll show you those results for 2 of the groups. And then at the end, we did a meta-analysis, which is a pooled analysis of all 6 of these to try to get what a global result was. That's the overview, and I'll step you through these one by one. The first is the propensity scores. And the propensity is basically if you imagine starting an experiment from the beginning, at the start of time, it's estimating the probability that a fish stock would be certified based on attributes which could be potentially confounding. We want to match between the control and treatment. And we use this to eliminate control stocks that are not intrinsically similar to the treatment stocks, the certified ones. And we looked at a number of attributes, and you can think of what they might be about the management system or how the fish were caught, or you can think of a lot of ones. And we tested a lot of ones. The ones that turned out to be most important for the propensity scores were the fishing mortality rate at the start of the time, and stocks that have low fishing mortality at the beginning are more likely to be certified, as you might expect. And the other factor that turned out to be important was not where the fish was caught, but where it was sold. Because there's a high saturation or a high uptake of eco-labeling in Europe, fisheries that sell their product in Europe are more likely to be certified, irrespective of where the actual fishery took place. So those are the 2 factors that really drove the propensity scores. So this is kind of shorthand, but we fit a model to that. We estimated the propensity score for each of the stocks, and we get a distribution of this. The propensity score goes from 0 to 1, and high means that there's a high probability of certification. And so you can see the black ones are the ones that are certified, and they tend to have higher ones. And the non-black ones are all the controls. Propensity scores give us a way of matching the control and treatment stocks. We want them to be similar, so we chose the interval here that's overlapping. So the gray ones are the stocks that were accepted as controls, and the white ones are ones that were dissimilar and were rejected. And this is the way we ensured, even though we had to forego some of the data, we ensured that we had a good similarity between our treatment and control stocks. So having then subsetted this, these are the ones that we're actually going to analyze, and we look at the trends over time in those control and treatment stocks. First of all, we had to normalize the data. For fishing mortality rates, we standardize them by their reference levels. So here's the F over its reference level. So 0 means it's at its reference level, positive above, negative below. And for spawning stock biomass, we simply use the log transformation, and that kind of takes out the overall magnitude of the stock. That's our data normalization. So the analysis is basically fitting trends over time to fishing mortality and spawning stock biomass. So I showed here for fishing mortality, and there are a number of things that I point out here. So the time scale here is before and after. So the 0 corresponds to the year of certification. What we're not looking at a snapshot of, in a given year, what's the status of the certified stock. We're not really looking for some kind of shift before and after. What we're looking for is the trend over time. And this is because when a fishery goes into certification, certain improvements were made pre-certification as it's kind of applying pre-certification. They're already making improvements to the fishery, and you expect the status to be improving up to the point where it becomes certified. And even when it becomes certified, often there are conditions that are imposed as a condition of the certification. And so improvements continue to be made over time. And so for that reason, we're really looking at the status not as a single point, but basically a time trend towards a greater sustainability. So that's why we have a window that is 5 years before and 5 years after, and we're fitting time trends, in this case fishing mortality, over that period. So what we've shown here is the slope for the fishing mortality rate. The black is the certified stock, and the red in this example, would be uncertified. And it's the difference in slopes that we're interested in, not the overall slope. So the linear model is something like this, where we have an intercept, we have a time trend overall, and we have this time certification interaction. And it's really this term, this B2 term, we're looking for a difference in slopes between the certified and non-certified. In this case, you see the fishing mortality of the certified stock appears to be declining more rapidly than the uncertified. So that would mean that certification is having a positive effect, that there's actually a benefit. And it's not the overall slope, it's the difference in slopes that we're looking for. So that's kind of a toy example, and now I'll show you two real examples. The first one is for the place in Europe, European place. It was certified in 2009. So the certified stock is in the North Sea. It's a little fuzzy, but there's the certified stock in the North Sea, and there are 4 control stocks of place over that time window. These are the results. So it should look similar to what I showed you already for the place. On the right, on the left is the spawning stock biomass, and the right, the fishing mortality rate. So we're looking at the trend in spawning stock biomass. The black is always the certified stock in the North Sea. So you can see all these stocks are trending upward, but the trend in the certified stock is greater, and it's significantly greater. So we see a significant improvement in spawning stock biomass. So that's the effect that we're actually looking for. Conversely, in fishing mortality rate, there we expect declines, and all the stocks are declining over time. The certified stock, the black one, is actually, its rate of decline is a little more negative, but you can see it's very subtle, and that difference, although it exists, isn't a significant difference in fishing mortality rate. So that's the place. Basically, the place is kind of a success where things are changing the way you would expect, in the sense that the status of the certified stock is better, significantly better than its control stocks. I'll contrast that with the SAIF in Europe. There are 2 certified stocks, one in the North Sea, one in the Northeast Arctic or Barents Sea, and then there are 2 control stocks here. For SAIF, the spawning stock biomass of all the SAIF stocks is actually declining over time. And in fact, the spawning stock biomass of the 2 certified stocks, the black and the red, is actually declining at a faster rate, a significantly faster rate than the 2 control stocks. So that's in the opposite direction that we would expect. And then the fishing mortality rate is going up for all the stocks, and you can see that it's going up at a significantly faster rate for the to certified stocks. So for SAIF, it really looks like the certified stocks, their biomass is going down as the fishing mortality rate is going up. So it's really not what you would be looking for. In fact, the fishing mortality rate at the beginning of the period here, the beginning window, was at or below this reference level, but then since increased. So it's kind of going in the wrong direction for SAIF. Yeah, that one was hidden. That one was supposed to be hidden because at 5:30 I didn't want to overbear you with equations. But this is a kind of summary of our results. So, and I'll just walk you through it. So on the left, again, is spawning stock biomass and right fishing mortality. And this is looking at the difference in slopes and relative to zero. So a positive, for spawning stock biomass, a positive value means that stock, the certified stock, is actually doing better. It's increasing at a faster rate than the control. And you can see that was the case for the plaice, which I showed you. It's also true for the hake and the rock lobster that we see a significant improvement in status over time. It wasn't the case for saithe, which I just showed you, and for herring and pollock, there's really no difference between the control and the treatment. We did a meta-analysis, which is really, a meta-analysis is a combined analysis of independent studies. Here the independent studies are the different taxa. And so when we do our pooled estimate by shown by the diamond here, the points of the diamond are kind of showing the confidence interval. So you can see overall the difference in spawning stock biomass is positive, but it's not significantly positive overall. So by contrast with the fishing mortality rate, we want fishing mortality rates to go down for the stock to be sustainable. For most of the stocks, there's really no detectable difference. And then for the two of the species, there's actually the fishing mortality of the certified stocks has increased relative to the control. So it's going in the opposite direction. And overall, we see kind of an overall increase in fishing mortality rate, but not significantly different from zero. So those are our tree diagrams, and the next slide really just summarizes in words what I just showed you there. For spawning stock biomass, 3 of the 6 taxa certified stocks showed greater improvement compared with non-certified stocks, so that's kind of the effect we were looking for. But overall, across the 6, there's no significant certification effect. For fishing mortality rate, we didn't see any overall improvement or decline in fishing mortality rate of the certified relative to the control stocks. And for 2 of the species, actually, the differences were in the wrong direction. That is, they had significantly higher trends in F and lower overall performance. So conclusion is, we go back to our research question, was do MSC certified stocks show greater improvement in stock status when compared to uncertified stocks with similar stock status in economic markets? And we found that while MSC certification may improve the resource status of some stocks, but we really see no evidence that it's actively reducing fishing pressure on certified fisheries. So by way of discussion, the first thing is we're really making a distinction between driving improvements versus identifying healthy stocks. So certainly, if you look at a point in time that the certified stocks should be sustainable and healthy, but what we're looking for is the dynamic. Is the certification driving a trend towards improved sustainability or status? And that's really what we don't find strong evidence of. So the next question is, should consumers pay a premium for the eco-label products? How does that affect us as consumers? How does this information make it easier or harder for us to buy seafood? And on one hand, I think that having the eco-label is somewhat reassuring in the sense that you can be assured that the product that has the label is sustainable, and importantly, the fish that's in the package is probably the same fish that's on the label, which is not always the case. So that's reassuring, with perhaps a few exceptions. There are some fisheries which are quite contentious, and people have thought that the standards of the MSC have not been upheld for those fisheries. But with a few exceptions, I think that it can be useful information. I think the problem comes with what about the seafood products that don't have the eco-label? What does that tell us, or what are the implications for things that aren't certified? Because there's kind of an implication that because they don't have the eco-label, that they may not be, as good or as sustainable. And I think that's really where our dilemma arises, in the sense that some of these products, certainly in the US where we have pretty strong fisheries management, some of these seafood products may be, equally sustainable to the ones that are eco-labeled. And so the question is, should we shun them, or in a sense, should we penalize those fisheries just because they haven't made the decision to actually invest in the eco-label? I think that the American lobster is actually a good example of that, because on one hand we have the Maine lobster, which is certified, and then on the other hand, we might have a Rhode Island lobster, which hasn't in the certification label. And is there a difference in those two lobsters? Just because is one actually more sustainable than the other, even though they're managed by the same management agency, same regulations? Should you choose one over the other? So I think that's really kind of the dilemma for the consumer. And we would hope that if there was one eco-label, that there would be ultimately there should be some measurable benefit from the ecological side to actually justify that distinction. And that's the difference that we found it quite difficult to measure. The next question is, should fisheries invest in eco-label? So I'm going to leave that one to just as a segue to Hiro's talk. And I'll just say, for our future work, we've looked at these 6 marine taxa. We want to also extend this analysis to sockeye salmon in the Pacific, where there's quite a rich database, and we feel that we can make the same comparisons for sockeye salmon. So good, I think that's my spiel. So I think we're going to hold questions, and I'll turn it over to Hiro.